every now and then we get these support calls where it's like, hey man, we are connecting remotely and connection is slow, or we have issues. Sometimes we can't connect. What's the problem? Now, this came to mind because we had a person that was actually offshore and they were having problems connecting to their corporate network. And, they reached out to us and said, hey, we don't know where the problem is. In their case, the problem was their internet service provider, which was another country, and all kinds of stuff. But it kind of prompted me to, we should maybe do a video on some basic troubleshooting steps that we can do to kind of, even if the problem is on your ISP side, sometimes you have to prove to your ISP that the problem is on their side before they'll do anything. I mean, even in the U.S., that's the case a lot of times, and in other countries, especially we go in Asia and stuff. We have to really prove to them that the problem is on their side, and even then, a lot of times they won't do anything about it. But that's a whole nother video. So how would you go about troubleshooting connectivity issues? So Mac, what I'm going to do is we are going to go into a command prompt, and we'll share that command prompt screen with everybody here, and I will walk you through it. I mean, how better to learn than somebody, walking you through it instead of doing it for you. Okay. So let's do this. Let's click on the Windows logo and type in C as in Charlie, M as in Mary, D as in David. So now what we're going to do is the first thing we're going to do, since you are having connectivity issues, is we want to identify if the connectivity issue is between you and the internet, or is it between wherever you are and your server side. Basically, that would be like your corporate office might be having issues. So an easy way to do that is to run a ping test to Google's DNS servers. So Google servers are, one of the best connectivity out there, that they have one of the best connectivity. I mean, they rarely go out. So we are going to ping Google's DNS server. This is a domain name server. You don't have to worry about the acronym. It's just an IP address. Now, the Google's DNS server IP address is 8.8.8.8. So what we're going to do is we're going to ping it. And what that means is we're going to send a few packets to that server and see how many come back. So Mac, let's go ahead and type in ping. That's P as in Papa, I as in India, N as in Nancy, G as in George, space 8.8.8.8. So that's 4 8s separated by periods and no period at the end. That's it. So now go ahead and press enter. And we're going to look at a few things. So one of the things that I can see right here is Mac is probably on a wire, some sort of a high lag connection, like not a LAN connection, because if he was on a LAN connection, normally even the first ping should be about 19 milliseconds. But notice how the first ping took a little longer, 39 milliseconds. And I'll move the cursor over it. So it took 39 milliseconds over there. And then 19 milliseconds, 17 milliseconds, 15 milliseconds. You see how it got better. But in this case, there is no lost packets. You see down here, it says loss is equal to 0, and it says 0% loss. Now, this means he has good connectivity. Down here, the minimum amount of time it took for the packet to go out, hit Google server, and come back was 15 milliseconds. Maximum was 39 milliseconds. Now, normally, these numbers are not very beneficial, but they help if you are on some sort of a VoIP type connection. So if you make calls from this machine, that difference between the minimum packet return time and the maximum packet return time is called jitter. Now, normally we don't want a high amount of jitter on your connection. So the ping times should be pretty close to each other. The more jitter you have, the worst quality of voice you're going to experience on that connection. In this case, it's not too bad. And so we did get a lot of information just by doing this ping. But let's say the 4 ping requests we sent and replies we got, let's say if one of them timed out, that would tell us that, yes, there is some connectivity problem, which in this case, there's not. Now, the next step would be to find out where that connectivity problem is happening. Now, the way internet works is your computer connects to your ISP's, well, it connects to your ISP's router, your ISP router connects to another router, another provider router, another provider router. Eventually it gets to its destination. So there's all these what we call hops in the middle. So all these hops have to send those packets through for a connection to be good. What we're going to do next is we are going to send a packet out and we're going to trace every hop. So we're going to see what the IP of every hop is and what kind of times each hop is taking to respond when we go and hit the Google's DNS server, which is the 8.8.8.8. So let's type in trace, that's TRACE, short for route. So basically that word, that command is trace route. It's just abbreviated trace RT and then space. And we're going to put in the same IP address we used before, which in this case is Google's DNS server. It is 8.8.8.8. And while Mac types that in and presses enter, Google has two DNS servers that are publicly responding. One is 8.8.8.8. The second DNS server is 8.8.4.4. Now, these are farms of DNS servers that respond to these addresses. So even if a few servers are offline, Google doesn't break because there's a farm of servers, right? So now it is doing a trace, and now this information here is pretty good. So I can see that Mac is on a private connection. It's 10.0.0.1 is his router, and that's probably his ISP's router, whatever it is. And then the next hop is 96.120.17.125. Now that's some router between Mac's connection and the next hop up. So all these are hops. So hop number 2 was that 96 IP address. Hop number 3 is, it's Comcast. The way I know it is in that URL, I see Houston.Comcast.net. So a lot of information on hop number 3. You can identify that, somewhere on his line, he's using Comcast. It's in Houston, Texas. It has the IP address. So a lot of info here. Now, notice how the second, third, and fourth rows have some numbers in them. Those are the amount of time that hop took. In this case, 15 millisecond, 13 millisecond, and 11 milliseconds, right? So now if one of those had timed out, or if all of those had timed out for hop number 3, then that would mean that hop is where the problem is, which would mean that the problem is on Comcast network somewhere. Now, if we gave that IP address to Comcast, it will make their life so much easier to figure out where the issue is. And a lot of times they're going to come back and say, yeah, there's a upstream server that is having some issues. A router is being worked on. We should have it resolved in a couple of days or in a day or whatever it is. Now, this is probably a residential connection, I'm just assuming. And in that case, Comcast is going to say, hey, this is a residential service. We only guarantee so much on a connection. You're fine. It will come up when it comes up. We don't have any other information. And we encounter that quite a bit when we are talking to residential service providers. But there's a lot of other good info here. So right now, if I go down, look at hop number 6. You see the first time we hit 46 milliseconds. That is not something to get worried about, but that is pretty good amount of lag there on hop number 6. And that is on ibone.comcast.net. Still within the Comcast network, but one of those routers, and it could be that router is just busy, that router just has some issue, some packet loss, or just it's being used a lot. There's a lot of traffic flowing through it. There is some lag on that. The 3 packets we sent, there was the one packet took a long time, 46 milliseconds. The other packets are fine, 18 millisecond, 12 millisecond, that's fine. Now, if we were using a VoIP type connection and we were having some quality issues, that is the hop that would possibly could be causing it because of that jitter. Remember we talked about the jitter? That 46 millisecond and then normally it's 18 or 12 milliseconds. That's quite a bit of jitter there. The difference is a pretty good sized number. But as you can see, it made it all the way down to Google's DNS server. Now, what this trace also tells me is that Google's DNS servers are 14 hops away from wherever Mac is, right? It took 14 different hops and it hit Google's DNS server. So the 14th hop is Google's DNS server. Not a lot of hops. I mean, we've seen like there's been. I mean, I've seen like 60 or 70 hops, especially when you're going across countries. You'll see, 60, 70 hops before you get there. But this is a good way that you can test, number one, connectivity, how clean of a connection you have, how much jitter you have on that connection, which impacts real-time traffic, whether it's video or voice, especially real-time voice when you're on the phone with somebody, and if you have that echo or you can barely understand somebody, it's usually due to jitter or packet loss, and you can find that out from here. So that's just what I wanted to touch on today. A few of these tests you can run just to see where the issue might be, and then call your ISP and tell them, hey, it's hop number, for example, 6. That has a high lag time on it, and maybe that's where the problem is, and that's on IP 96.110.40.121. Now, another question that might come to mind to people are probably thinking who know a little bit about IT is, hey guys, how come you're showing us your IP address, your subnet, which in this case is 10.0.0.1, which is the router that's closest to Mac's machine, Mac's actual computer. So guys, these are private IP addresses. You cannot hit them directly from the internet side. The 96.120.17.125, that's a public IP address. So don't worry about it. There's nothing confidential here. AI gives us some information. The only information we get is Mac is in Houston. He's using Comcast. That's pretty much it. So there's nothing really that can identify where Mac is. That only happens in movies, not in real life. But I hope that helps out somebody. And if you have questions, if you want to see more videos like this, a little more on the technical side, let us know. Give us feedback. This is something that people have requested, and a lot of times on support, we've had to walk people through this to do these tests. And if you can do it on your own, hey, great. You can solve some of the problems on your own without having to call for support. So do you have any questions for me, Matt?
No, this was interesting. This is the part of what you do that I don't really see on the regular. So, honestly, I did not know I could do this.
Yep.
This is interesting.
Now there are some few other things that we can do. So if you push the up arrow key twice, the ping command will come back in there. So just push it 2 times. Yep, there you go. So ping. So here's another interesting thing that we can do. We can give a few switches to this command, and basically we can send a specific size packet to Google's DNS server. And sometimes that is helpful. I'm not going to go into the details of why sometimes it's helpful, but I'm just going to give you a few things, a few tricks, so to speak. So go ahead and type in, just put in a space, minus L, so the minus sign, and then L as in Lima, space 1500. Now, what we are doing here is I'm just telling the ping command that I want to send packets of size 1500. That's the length of the packet. So I want to send a maximum transmission unit. Don't worry about it. I was going to say MTU, but I use the full word just so people understand. So the maximum transmission unit size is going to be, or the maximum packet size is going to be 1500. The idea is that I want to see which routers are not allowing packets of that size to go through them. Because routers don't allow unlimited packet sizes. They only allow certain packet sizes to go through. Now, this is probably going to work. Let's see if it does or if it does not. So, and I chose 1500 for a reason. So go ahead and press enter, Mac. Let's see what happens. And it did not work. So there is something.
Okay, go ahead.
So there is something on this connection that is not allowing a packet size of length 1500. And here's the reason why. So the reason I chose packet size of 1500 is because the maximum transmission unit size on an Ethernet network is, when you're connected via cable, is 1500. Now, so in this case, I'm telling it, hey, send a packet size of length 1500. You're on a wireless connection, so your wireless network probably is not allowing packet size of 1500 because there is some overhead. When you're using wireless or cellular or any other thing, or even VPN, there is little overhead that is embedded in each packet. So that overhead is making that packet bigger than 1500. When we say send a packet of size 1500, that packet is actually a little bigger because the wireless authentication and all that info has to be in the packet as well. So that's, encryption and all that. So that makes the packet bigger and the router cannot handle it. Now, let's do this. Let's push the up arrow key one more time.
Oh, one more time?
Yep.
Okay.
And then push the backspace key. So we're going to change the 1500 to 1400, which should go through.
And press enter?
Press enter. Yep. And it went through. Now, interesting thing, it went through, but notice the time. Look at how the time has increased. Before it was like, 12, 15, 16 milliseconds. Now it's like 70, 64, 11 because the packet size is bigger. Now, even though Mac is on a wireless network, with the 1400 size of packet, even with the Wi-Fi overhead, the packet was able to make it through to Google and come back, right? Now, there is a lot of interesting things that happen when this transmission is going on. If the equipment cannot handle a certain packet size, a lot of times it will fragment the packet. So even though we're saying it's 1400 packet size, if a router doesn't support 1400, the system is automatically fragmenting it and then sending it in multiple fragments. So we can do another thing. So Matt, let's do up arrow key one more time. And this time, we're going to send a packet of size 1400, but we're going to tell it, do not fragment this packet. I want to send the whole packet. So go ahead and press the space bar and then minus, and then F as in Frank. So F means fragment. So we're going to say minus F, don't fragment, and press enter. So notice that it is going through still. So even with the fragment bit, do not fragment bit set, the packet is making through. So what that tells me is that Mac's network is able to handle a packet length of 1400 with no problem, even without fragmentation. This comes in handy when you're on a VPN connection. A lot of times a 1400 packet size will go through without the do not fragment bit set. But if you set the do not fragment bit, use the minus F, it will not go through because the VPN overhead is going to be enough to where the 1400 of your packet size plus the VPN overhead, you combine that, is going to be beyond 1500. A lot of the routers in the middle are not going to allow that. So I'm not going to get too technical. I just wanted to say this is how you can test for what packet sizes are being allowed. And this has saved a lot of network admins a lot of hassle trying to figure out why, when you're copying a large file over a certain network, it times out and errors out. But when you're sending a small file, it works just fine. Those kind of weird issues, okay. This is how we detect that.
Okay. Wow. That's good to know. Wow.
Yeah,
wow.
it was, and I'm not going to go into too much detail. We're already 24 minutes. Maybe I'll share this story another time, but it really saved. We had a multi-location customer that came to us because they were having problems and nobody could figure out what was going on. It was like there were gremlins on the network. This shouldn't happen. Everybody was scratching their heads. And this is how we figured out where the problem was, what the problem was, and what the solution was going to be. So for now, I think this is good. Try this next time you have some connectivity issues. Hopefully it helps you out. And like Max said, subscribe to us, give us thumbs up. It always helps. It helps the YouTube algorithm. And we'll see you next time.
We'll see you guys.
Have a good one.